Good morning, everyone. This is Greg Corrala. Just wanted to let you know we'll be starting in about 1 minute. All right, well, good morning, everyone. My name is Greg Corrala. I lead our business development team for database analytics at AWS. And joining me this morning is Colleen Camuccio, Vice President of Program Management at Dow Jones. We'll be talking about a case study of how her organization was able to use data lakes and analytics on AWS. And so today's topic, building a data lake and analytics, and we'll start off with a quick overview by myself, just so we're familiar with the basic capabilities and value of building a data lake on AWS, and then Colleen will run through a real example of how Dow Jones is able to take advantage of the capabilities that we'll be discussing. So I think, if we think about the landscape for big data and analytics generally, or just the nature of data that we gather in our organizations today, we understand that there's no more data sources in terms of social media, in terms of Internet of Things devices or log data. That really comes down to additional data types, whether it's more data, the speed at which data comes in, or the variety of data types. That really has been a trend for the past 10 years, where newer ways of doing analytics or getting insight from data requires this data lake framework, which means moving beyond just a simple relational database to store our data, because not all the data can conform into the relational database framework, but can still provide key capabilities. And so if you've heard the volume, variety, velocity, the 3 V's, but then we add some additional V's just to kind of build out the story, it kind of just says that, hey, like traditional ways of processing and analyzing data isn't always effective in the modern environment in which we operate in. And so I think that data is growing faster than ever. The variety is growing. I mean, there's lots of analysts and media reporting in the media about this trend. And really, it's not just about data is growing or insights in terms of getting deeper insights into data, but also how do we unlock we call the dark data, or data that historically was not cost effective to store and analyze, but can still provide value. And so can we essentially take advantage of all the data in the organization, and not just the data that can fit in within a relational database. Sorry, I'm just trying to get to the next slide. There we go. So if we kind of set the scene, so in terms of the the 3 V's, volume, variety, velocity of data, plus additional V's in terms of new insights and sources. And I talked a little bit about how the traditional relational database might not fit all this data. And so this trend towards a data lake, like how does it actually help us address 3 key problems? And the first is I want to be able to quickly ingest and store any type of data. So it can be structured data, unstructured data, log data, data in formats like JSON that have come from different devices, and not have to worry so much about conforming it into a single schema, for example, right? And so quickly, within a matter of seconds or less than a second, ingest the data, particularly if it's a stream. And then this idea of a single source of truth, I mean, it's sort of been the goal for decades probably, right? But by this, we're just saying, look, instead of building silos of data, so like a traditional setup, a data warehouse might be one source of data, a Hadoop cluster might be a second. And then, this makes it very difficult to do analysis across those two systems. And so if we can think about a data lake pattern that, combines all of our data, we really can get closer to this idea of a single source of truth where we aren't tied to a single analytic tool in terms of only its capabilities to load data into one place, but being able to take advantage of the data in any format to do the right analysis. And then, that kind of comes to the third point we call out here, which is let's understand the right tool for the right job. And so if you, say, like, my quote unquote data lake is going to be my data warehouse, then, all the questions you can ask of that data are constrained by what that particular database supports, right? And what we find in many organizations today that there's a mix of analysts that understand the SQL language and perhaps are using a tool like Tableau or MicroStrategy to run reports and dashboards, but there's a separate group that's using Apache Hadoop and languages like Python or Java to programmatically express their questions. And this idea that can we have a world where both of those use cases can access the same data or the data lake, but in dramatically different ways, but a common set of definitions is really the idea where we don't have to make compromises in terms of the analytic questions we can ask the data. And if we simply have a single store of data, then oftentimes we are forced to make that compromise because we're limited by what one single tool can provide. And so we want to bring the analytics to the data and not the other way around. And so, kind of setting the stage there, and this is, we'll dive into a little bit more detail, but fundamentally, we think about these functional areas for a data lake, right? And I called out, there has to be a layer, to ingest the data. And we want to think about, the different ways of ingesting it. So if it's a stream of data coming from a device or a mobile application, perhaps this is, real-time data movement, right? Where, data is continually coming in from hundreds, thousands, perhaps even millions of different devices, right? But then there's also, the traditional data environment. So perhaps I have transactional databases that are collecting orders that, I potentially could have a non-relational database that is powering my application as well. And so we also just need to think about, ways to, connect my either on-premise or on EC2, Amazon Web Services, Elastic Compute Cloud to, load the data into that storage layer, right? So lots of different ways and many, rich ecosystem of tools to, take advantage of both the structured data as well as the streaming data. But essentially now have, this data consolidated on a single data lake. And if you're familiar with AWS, you'll understand I'm quickly getting to the idea of Amazon S3 as the landing zone for this data lake. And the nice thing about S3 is that it provides an object store, so you can load essentially any type of data into it. But the difference between kind of having a data lake and just having a collection of raw data really comes into the second point, which is the catalog that we'll spend a little bit of time discussing. But it's this catalog that provides the metadata layer on top of the storage so that we then feed into the top component of this chart, which is really the intelligence, right? And if I have a common set of definitions of the data, if I have a common security and access control model where I don't have to worry about granting access to individual files, but to metadata objects that then drive the permissions and audit and compliance components. And now, I have a much richer set of not only, historically looking analytics, but importantly now moving towards predictive analytics with machine learning. And so, we'll talk a little bit about more detail of these, but these are kind of the three layers we typically, refer to in terms of what constitutes a data lake on AWS: the ingestion, the storage, and then the intelligence that we can drive from that data. So how do you really drive, value from this? And this kind of is a little bit a different view in terms of, the capabilities we discussed on the previous slide, but now overlaying some of the AWS terminology in terms of the breadth and depth of AWS services that organizations can use to analyze the data. And so depending upon how we're ingesting the real-time data or doing the, connecting it back to our on-premise databases to load structured data, the machine learning and analytics. I don't, plan to go through each of the terms on here. I will, pick out a few key ones that we think we commonly see. But, the idea is that we have this rich ecosystem to drive value from data on AWS. And we want to partner with each of you to, work with our solution architects and teams to pick the right architecture that can support your use case. And we actually think having a larger breadth and depth of capabilities gives you the richness of the type of analytics that you can drive. And knowing that with some of the key concepts of a data lake, such as separating compute and storage, and having open file formats, such as Apache Parquet or ORC, which are common in the Apache ecosystem in terms of the file format on data, really provides you a flexibility to say, today, perhaps I have a set of questions that can be solved through a service like Amazon Athena that we'll be covering. But in the future, I might have a quick experiment that can say, well, I really want to understand the power of search. And so using something like Amazon Elasticsearch Service to get access to data. And, yes, we can definitely, provide guidance in terms of how it can be successful with a component or an architecture that can combine these services. But equally as important, we want to provide a cost-effective way for your organization to quickly experiment and try something out. And if we can really make the cost of failure super low, meaning that if I have a question or an analyst has a solution architecture stack that they want to stand up in maybe a few hours or could potentially be minutes, test out their idea, and if it's successful, put it to production. But equally as important, if it's not, I can quickly turn it off and not have to be locked into long-term hardware or software contracts. And so this idea of experimentation, I would argue, really drives innovation in terms of accessing data in new patterns and really allowing teams to choose the right tool to answer questions for their particular business without having to be locked into a solid or rigid solution stack. And now, a little bit in terms of, the market. So depending upon, the different analysts that are out, we chose here a quote from Gartner that, throughout 2018, 80% of data lakes will not include effective metadata management capabilities, making them inefficient, right? And, this talked about, I kind of talked about this a little bit earlier where, I talk to a lot of customers that say, hey, I have a data lake. I collect all my data into, system X, whatever that might be, and I'm good, right? Except that, if we really think about the end goal, which is to empower an analyst to ask a question of the data, just collecting the raw data oftentimes leads to a, data swamp, right? You might say. And we really want to make it easy for analysts to discover the attributes and the data that exists in the data lake without having to search the raw files. And so this concept of the metadata layer on top of the storage becomes, really critical. And so to help solve that, sorry, just waiting for the slide to update. So we have AWS Glue, which has a few different components. And so if you think, I kind of talked about the ingestion layer and I gave some descriptions of different, AWS services, at least in terms of the names that we can think about, whether it's a stream or a transaction or on-premise database to load the data. Typically that data loads into a storage layer. The storage layer oftentimes comprises of Amazon S3 in terms of the object store. But now we want to spend a little bit of time on this concept of the data catalog. And so within the AWS ecosystem, we have a service called AWS Glue that can really, discover the data and provide that metadata catalog. And so as the name implies with Glue, it's the piece that stitches together an analyst that has a question in the data that sits on the data lake. And it's not just a matter of having to manually enter the definitions, but there's sophisticated capabilities within the Glue data catalog that will actually discover the metadata for you, meaning that, with the appropriate permissions and security groups, it can, detect the data format, interrogate the data format to understand the metadata that is encoded directly in those files, such as Apache Parquet or JSON, and then present that back, right? And then if I need to transform the raw data in terms of, converting it from, let's say, CSV or JSON into one of the open formats, such as Apache Parquet, we can actually author a Python or Scala programmatic job using Apache Spark in a serverless environment to transform the data and then execute and deploy that without having to think about infrastructure configuration. And so these different components of Glue, whether it's the data catalog, the job authoring, or the job execution, are completely serverless. And so you simply think about the capability they provide without having to manage the infrastructure to support them. And then, you think about one of the key tenets I called out in terms of the data lake, which is this, multiple different types of data formats that I can collect, and that the catalog, or the AWS Glue data catalog, provides a translation between the raw data and the actual analyst that has a question. And so I wanted to just double click a little bit in terms of how the Glue data catalog can detect, and not only detect, but also provide the metadata around those components. And so we automatically send out something called crawlers that you can schedule, that you can define, again, governed by security and access control rules, of course. But the crawlers invoke something called a classifier, and the classifier will go out and look at, the file, whether it's JSON or XML or CSV, for instance, and actually come back with the definition of the data. Of course, there can still be a small group that wants to modify these definitions or add, additional descriptive tags to them to make it a little bit more amenable to the business to understand where, what a particular data item presents. But the idea that the crawlers can run, they execute the classifiers, and we have a rich set of default classifiers that can look at, not just, row-based XML or JSON data, but a rich set of classifiers for common Apache formats like Parquet and ORC that can essentially present back the definition of the data based on the information in the file itself. And if you have a custom file that perhaps doesn't have, one of the default classifiers in AWS Glue, you can actually write your own classifier, and so it can be extended through third parties as well as internal development to really take advantage of this powerful metadata layer that can interrogate the data on Amazon S3 and come back with the definition. And so there's lots of other ways to kind of populate this data. So I kind of covered this automatic process with the crawlers and classifiers. But, of course, depending upon, if I'm doing a proof of concept or just a test or evaluation, you can always just, create a table manually. And it's important here when we think about this concept of creating a table or using data definition language, or using the API, some of the examples we have here, it's important to call out that we're not physically changing or conforming the data into a separate physical structure. We're simply providing a metadata layer. Sometimes this is referred to as schema on read, where we're just looking at a definition of the data without having to modify the file. And so I could have, one or many different files and have different definitions of that data that can be, presented back to business users or analysts to look at the data without having to conform it. And the reason I kind of call this out is that it's dramatically different than perhaps a, data warehousing approach, where oftentimes a large part of the effort is conforming data into a relational schema, where we have to go through, very elaborate extract, load, and transform statements to get the data in. And then, of course, if I have a new field or a new object I want to load into the database, I have to change the schema. And that's typically referred to as schema on write. And so in this way of publishing the catalog through crawlers or through manual table creations, we're simply providing a schema on read, which we provide the schema on top of the data sets. And it can really be a lot more flexible in terms of the power of exposing the data without having to worry about how I manage changes or conforming it into any one particular structure. And then, so we talked a little bit about, ingesting data and then being able to provide the storage, an object store, Amazon S3 to have the data and the capabilities of the catalog. And now I just want to spend a few minutes to kind of highlight a few of the capabilities with the analytics that I can actually drive from the data that's defined in the data catalog. And the first is, I've been talking about the idea of a data warehouse and kind of some of the pains that customers go through in terms of conforming or loading data into the data warehouse. But at the same time, it still is a critical component of many organizations' ways of analyzing data. So if you're using, a tool like Amazon QuickSight or Tableau or MicroStrategy and kind of this rich set of tools that we have, listed here, plus others that are using dashboards or reporting. If I'm looking for a traditional cost-based optimizer that a relational database provides, then Amazon Redshift is the market-leading cloud-native data warehouse that can really provide that high-performance way of analyzing data. And I can leverage the data lake in some cases, to load data into my warehouse if it makes sense for my use case. And in being able to start with, gigabytes going all the way up to petabytes, if I need to actually load the data still into a data warehouse, you can simply use Amazon Redshift to be able to do that analysis. So I'm just waiting for the slide to update. Now, beyond just the data warehouse, kind of where does the data lake fit in? Well, in many times the data lakes can really extend the traditional data warehouse. And so if I have, Internet of Things devices or web data or social media, oftentimes, this idea of interacting and having data in these different, capabilities exposed through a common data lake becomes really, really powerful, where I might have, individuals using, machine learning algorithms in Python or, running analysis in an Apache Spark container and programmatically accessing that data, but still loading a subset of that data into my data warehouse that can then be combined with more traditional transactional sources. This idea of, we're not replacing the data warehouse necessarily, but really extending the capabilities that can be provided. But what we've seen is that, a great trend where, many times analysts, they don't want to make a trade-off between a data warehouse and a data lake. They want to have a best of both worlds where I can have highly structured data in a relational database that supports concepts like insert, update, deletes that can be accessed through business intelligence tools, but still expose the richness of data in the S3 data lake. And so there's a capability within Amazon Redshift called Spectrum, where if my analysts primarily know the SQL language, I don't have to go through the extract, transform, and load process of loading it into the data warehouse. I can simply leverage that data catalog I mentioned earlier to query the data natively on Amazon S3 without having to load the data. So I inherit that schema on read and then, access it through simple SQL queries. And this helps me, take advantage of scaling compute and storage separately, because with the Spectrum capability in Redshift, I'm not using the local compute and storage of the Redshift cluster. I'm using a serverless compute layer we call Spectrum to query the data directly on S3. And so here's a little bit of a architecture view of this. I'll go kind of quickly through it. Happy to kind of dive deep. But the question, the point I would kind of call out is that to the analyst, they can simply use the same business intelligence tools, whether it's Tableau or MicroStrategy or kind of the names that I've called out earlier. But now they just have a set of tables. Some are local to Redshift to be able to get high performance, or if I'm doing fast lookups, I can take advantage of the local disks of Amazon Redshift. But now I can leverage the same Glue data catalog in the same set of files on Amazon S3, but to the analyst, they just see tables and columns and schemas, and it's really transparent to them, but it really gives a much greater flexibility of combining the concept of a data lake and a data warehouse into a single analysis tool. And then there could be, so Amazon Redshift, it's great if I have a data warehouse, if I'm using, BI tools if I kind of understand the access patterns, but there's also the idea of interacting with the data through Amazon Athena, where I just have a group of users that, perhaps they just query data once or twice a day, or, a few times an hour, where it doesn't make sense to have the full power of a data warehouse, but I simply need to just query the data, and the language that the analyst knows is still SQL or SQL, right? And so instead of having to make a trade-off of using a single tool for all use cases, we think the idea of having, Amazon Athena, where I can, really powerfully, in a completely serverless environment with no setup, leverage the same data catalog that Redshift Spectrum is using, but now, provide a sandbox for analysts to simply, query the data separate from the data warehouse. Or if I just need to do a few queries in terms of a few hours, maybe looking at compliance data or archival data on S3, just knowing that Athena is there, that really can complement the data warehouse and can complement Redshift. And so many times customers will end up using a combination of both. And what ties them together is really the data catalog in Amazon S3 that really provide that common data definition. So regardless of an analyst using Redshift, Spectrum, or Athena, it's the same data catalog in the same set of files on Amazon S3 that can really provide a richness or a set of tools that you can match to your solution architecture and your needs to see which one makes the most sense for your business and analysis needs. And so one of the last parts I'll then call out is then, being able to move beyond just the SQL language, where, oftentimes questions that we have need to be expressed programmatically through languages like Python and Scala, or being able to use the full richness of Apache Hadoop to add additional capabilities. And, because we kind of think about these open data formats on Amazon S3, defined through the single data catalog, yes, my marketing team or analyst team that knows SQL can, choose between Amazon Redshift or Amazon Athena for that type of analysis. But now we can really leverage the power of Amazon EMR to be able to use the richness of Apache Hadoop against that same data. And again, we want to leverage the same data catalog, as I've been calling out a few times, with potentially even the same set of files on Amazon S3, but really gives me a dramatically different way to do the analysis. And so if we think about the power of a data lake in terms of providing this, single source of truth, and if I separate compute and storage, and if I embrace the open file formats in terms of Apache Parquet or ORC or JSON, it really, opens up this world for the data catalog to support multiple different use cases and multiple different ways of accessing that data. And so, and I'll kind of wrap up in terms of, and pass it off to Colleen to kind of talk about, how Dow Jones was able to leverage this. But if I really think about the core tenets of a data lake, of course, we don't have to be in a world where we have a trade-off between Apache Hadoop or data warehousing, that they really complement each other. That's really driven by the access pattern or the use case that we want to support. And I want to think about, decoupling compute and storage and having a separate data catalog that essentially can be shared between these different environments of data warehousing in Apache Hadoop or data lake. And what it really means is that if I embrace this idea of open standard file standards, such as Parquet and ORC, with a common open metadata layer and a set of tools, I can really future-proof my analytics. And so, next year or 2 years from now, if the business changes, I don't have to, reload my data or do an extensive evaluation of different components, but simply, leveraging the data catalog, leveraging those open files, stand up a completely different stack. And so I'm not tied to a, single file format or single database. And my word of caution oftentimes is that if you talk to a vendor that says, hey, just convert all your data to my format, that's probably, a red flag. And so, because if I convert the data into a single file format that's proprietary to one execution engine, then I'm really tied to only the capabilities that that tool can provide. We really want to emphasize, choosing the right tool for the right job and being able to take advantage of the elastic nature of the cloud to be able to drive down cost and to really expose the richness of the data. And so those are, I think, the main points I want to drive in terms of the introduction. And now I wanted to turn it over to Colleen to really highlight some of these conceptual components that I've discussed in terms of how Dow Jones was actually able to use them. Colleen, it's all yours.
Hi everyone, Colleen Camuccio from Dow Jones. Give me a second as I advance through the slides. I'll have the same delay as Greg did. So we embarked on a program to build a new customer data platform because we heard the same challenges that I'm sure everybody else here is, that there's multiple versions of the truth out there, that people waste time looking for data, they have a hard time getting to the actual data that they're looking for. So in an effort to put data at the heart of our business, we set out to build a world-class data platform to house all of our customer data across the entire company. And data is more than just storing data for us. It actually becomes a way to fuel existing revenue streams. By moving to the cloud, we were looking to reduce operational costs. And at the end of the day, we really wanted to be able to have data easily accessible to our users so that it could promote more informed decision-making, and most importantly, really use it to improve customer experience on the site as well as the way we interact with them. So we ramped up an Amazon landing zone to start building on our platform, and I was really proud of the way we've kind of approached it. We had an architect, but we created an environmental council to help make key decisions around the architecture and help us decide what pieces would be the best to use. And we even had folks from Amazon on the council, as well as going through our well-architected review to ensure that we were really using the pieces that would get us the best performance and really get us to the best end state. We were trying to learn from our predecessors as well, where people kind of ran right in and tried to do everything all at once. But our approach to building the platform is more of a crawl, walk, run kind of phased approach, where we started with just very simply getting all of our data in there, worked on some basic visualizations off of that data, built up the history, did some transformations so that we could be able to do historical analysis, added more data so we could do clustering, and our end goal at the end of this is to be able to do predictive analytics and some really cool machine learning. But we knew we had to start from the beginning before we could get to the really awesome end. So this is our reference architecture. It's an eye chart, but a lot of the really key components that Greg has mentioned are within our architecture. So everything is based off of data landing in S3 buckets. We utilize EMR clusters to can do the ETL. We continuously refine, format, and store the data within S3. And then finally, we will use Spectrum and Glue to expose that data to the user. So we have very, very large data catalogs to make sure that the data is readable by our users. And everybody really gets access to our data via Redshift, and we utilize Spectrum to query the data within S3. And there's a lot of other really basic parts, but the thing that really drives our data lake is our EMR cluster, our S3 buckets, and Redshift. As we were thinking about creating our data platform, a lot of the users that we had involved in the program were very heavy data warehousing. So everything in their mind when we went to set out to do this was around land stage and eventually creating marts, but that's not necessarily what our end users needed. So we really wanted to set out to create a data lake while still knowing that there were reasons that we needed to create data marts. So we took our traditional warehousing concepts and used them to build up a lake. So everything really lands in S3 in its rawest form. And then we do some basic staging transformations. And the staging layer is really what we utilize as our data lake. So the data has been cleansed, it has been standardized and formatted, and then cataloged using Glue and made available to our users via Spectrum, and they access in Redshift. But we will take that same exact data and do additional transformations and eventually get to some end state that looks more like a warehouse that you're used to, but still stored in S3 as Parquet files. And eventually we will do some marting when it's necessary to do deeper aggregations and apply more sophisticated business rules. But still, even at that point, we're storing the data within S3 as Parquet files and giving users access to it via Spectrum. It isn't until we decide that there are some performance reasons, or maybe it's a tool set, that we will actually perform a copy command and create physical tables within Redshift. We had a lot of big decisions that we had to make when we set out. We were new into this space. There was a lot of new tools available, and we were working very closely with Amazon to make some of these really big decisions. So we were trying to decide what our ETL tool would be. So we were looking specifically at EMR and Glue. We did a very extensive evaluation. Glue was still very new in the ETL space at the time we were doing this evaluation. But we did decide to utilize EMR Spark and get developers that knew PySpark in order to do our transformations. It seemed to be the best option due to the large volume of transformations that we needed to do and the complexity of the transformations. And this allowed our developers to have the most flexibility. But the Glue catalog function still plays a really, really important role as our data catalog, so that we can define the schemas within Redshift, so that we can do all the appropriate partitioning to improve performance when users are querying. And we also did a lot of investigation about how we were going to give users access to the data. We did some really cool immersion days with our Amazon partners, and we looked at Athena and we looked at Spectrum. And one of the big things that played into our decision-making at the time was giving users access to data. We didn't want them to get the raw data. We didn't necessarily want them to have access to all of the data within the lake, because not every end user is sophisticated enough to mine it in those ways. And, you know, dealing with customer data, we are very protective of our customer data, and we don't want to just give everybody access to everything. So we decided to go with Spectrum because it was a much easier permissioning capability over Athena. We could create external schemas, create external tables, and provision users access even down to the table level. So that's why we ended up making that decision, although we do know, because we do go through regular reviews with Amazon, that some changes have been made on Athena recently that may make that easier and could possibly sway folks in either way. But Athena is something that we are still interested in utilizing, but for now, Redshift seems to be serving its purpose, and we're playing around with whether to store things as external tables or physical tables based on the number of business rules that have to be applied, the number of users that are using it, and what their queries look like. We do some extensive monitoring of how people are using the data to make better decisions about how we store it. Sorry guys, don't wait for my slide to move forward. So in order to derive value, that's kind of that so what. So we've put all this data in, it's now there, we've created a lake, we've done some transformations, we made a few marks. Where we really are driving value for our business is creating some really cool dashboards. So for our B2B partners, we've created a really cool 360 view of their customer by collecting data from various parts of the organization, joining it together in new and fun ways, and giving a really interesting tool to our sales folks for when they go out to speak to their clients. We've put droves and droves and droves of anonymized quick level data within our online engagement data lake, and we're giving users the ability to mine through and comb through piles and piles of really, really interesting data. But we've also done some aggregation and some business rules to give our folks a data mart so that we can really assess usage patterns, frequency, which is from a reporting and analytics standpoint, just some basic information that we're looking to get for our users. And the coolest thing that we've done most recently is around storing first-party data that our customers have given us. We interact with our users on different levels every day. They give us data by filling out forms and interacting with us. And any customer could give us any piece of data at any point in time during their life cycle. So we're storing all that within the lake, but we've come up with a really cool table in the warehouse where we're applying a lot of hierarchical rules that say if a user gave us the same piece of data 3 different times, which one is the most recent, which one's the most relevant, and did a bunch of standardization on that data because we could collect job title in a variety of different ways. But when querying, we're looking for more standardized values to give ease of use to our users. So we created a very popular mart where it's standardizing a lot of that information and giving some anonymized information to our analysts so that they can run some trending and clustering. So we've really reached that predictive analytics phase of where we are. So we're preparing and organizing the volume of data that we collect on our customers and completing out our data lake. And the Glue catalog plays such an important role in that for us. And we do a lot of standardization and keying so that as it lives in the lake, it's not really in its raw form, it's in a more cleansed form that's easy to use and allows us to join a variety of different data sets together. And then we're working on some machine learning so that we can train a model to triage and reject records as we process them during our ETL to improve our match rates during warehouse transformation. And then we're even looking to build additional models off of the actual data so that we can assess customer behavior. So we're really excited to start standing up SageMaker within our architecture. So the really key components here are around utilizing SageMaker because it will manage the Amazon resources for us and will help us spin up and spin down things as we need them. We really liked the plugin with Jupyter Notebooks. It was a very easy way for data scientists to manipulate data. And then they can access and read any of the data within our customer data platform, just as any other person would access via Redshift. But we also have created these sandbox areas for our data analysts so that they can read our data within the platform, create their own curated data sets that they'll need for a lot of their training and building of models, and also allowing for automation on the back end. So once a data modeler has come up with a model that needs to be run every day, it'll fit very nicely into our existing architecture so that we can have EMR do some of their transformations and have Airflow run some automation. And that's all for our side.
Great. Well, thanks, Colleen. And in terms of some next steps, and so I shared into the chat window here a link to a data lake on AWS, which includes a cloud formation template that actually can let you start getting going. But at this time, I think we're going to try to answer a few questions. And I've been answering some of the questions here in the chat window as well. So I think, 1 second. There were a few questions. Let's kind of review quickly some of the things I've answered. And I'll read some of the questions that are here in the chat. So there was a question about being able to use the Glue data catalog and what its components are. And so if you kind of review some of the material I said, well, yes, like the Glue data catalog is compatible, fully compatible as a Hive metastore, and it is a managed service from AWS, meaning that the Glue data catalog just exists, and being able to have that as a Hive metastore compatibility, but then it extends the Hive metastore with crawlers and classifiers that again can search out your data and come back with the schemas. And so it's not just a managed Hive metastore, but actually the ability to have the crawlers and classifiers to extend. And then there were some questions about can I use a different set of analytic tools against the same set of data? And of course, that's really the primary reason that we wanted to call out in this webinar that having a data lake on AWS really allows that flexibility of having multiple analytic tools against the same set of data. So I'm looking at other question. What's the advantage of connecting BI tools to Redshift instead of RDS? Well, I think that's a similar component where I talked about that, yes, BI tools, whether it's Looker or Tableau or MicroStrategy or Amazon QuickSight, lots of different ways that, you can really choose the visualization layer. They all support, standards like ODBC and JDBC, as we all know. And, being able to have this flexibility that can really match the capabilities you're looking for. And so, we think of Amazon Redshift as a data warehouse, meaning that it is a columnar MPP structure that can not only query local disk but also Amazon S3, right? And these are typically done for more analytic queries. In a relational database service, we typically see more for transaction processing. Of course, like they're both relational databases, they both support standard SQL. There is some overlap, but I think fundamentally thinking about this idea of data warehousing versus transactional databases is typically where I see customers make the choice. But of course, there is some overlap in terms of my data size, or depending upon the complexity of questions that I'm asking. And so I'm just going through some more of the questions here. What's the difference between Athena and Redshift Spectrum with regards to user query? So I guess my perspective would say, like, it's really not the user query or the difference as much as the use case that they support. And so if I have a common set of data on S3 defined through a single data catalog, we think it's better to give you a choice in terms of extending my data warehouse, my structured data out to S3, or just simply using Athena to query the data directly. And so I'm sure there are maybe at the edge some small differences in terms of the SQL, but we always work to kind of make that fully compatible. So I wouldn't really focus on the query differences as much as the access patterns and kind of the use case that those support. And so maybe, Colleen, if you don't mind, I'll just kind of take a break from the chat pattern here and maybe ask you a question directly. But if you were to kind of share with the audience, like what is the top lesson that you learned in terms of your journey with AWS, and is there any sort of words of advice if an organization was starting on a data lake that you wish you knew when you had started this path?
I think what has been so interesting, at least here at our company, is that we're embarking on a lot of new ground that I didn't quite realize. A lot of people at our company are using AWS services, but we were the first here to store data for the sake of using data. A lot of the applications that a lot of our users have built here in the cloud have been generating data, but the data is only allowed to be accessed by applications. So we ran into a couple of really interesting things, which is why we, made that decision about Redshift Spectrum alongside our InfoSec partners, because we are the first ones that are allowing people to access data for the sake of accessing data and accessing it directly. So there was a lot of additional considerations that I wish I would have thought about earlier on than kind of later down the line. And the other thing that I found to be the most interesting in working with Amazon products is there is multiple tools that will answer the same question. It's just a matter of how, but for us, it's a matter of how our users are querying the data that help us make better decisions about using EMR to do transformation versus just writing SQL queries, whether we should keep data in S3 and use Spectrum versus creating physical tables in Redshift. It's really all about how people are using the data, and that's how you should really center the answers to your question.
Yep. Great. And so I'm just going through some of the questions in the window here. So I think there's a couple of questions in here, Colleen. Maybe I'll ask you kind of on the fly if you can think about. But you talked about the kind of choice you had to start with Spark for ETL in your presentation. I'm just curious. There's a few questions about like how was that the decision you made versus some of the more visual environments, or were there combinations of the two that you used?
Well, we decided to use Spark specifically because we thought it was the best option to run big, massive amounts of data through transformations overnight and then make it available. Because there's an extensive amount of cleansing and formatting and keying that happens, even just in our staging layer, it seemed to be the most efficient tool to generate the keys for a large volume of data. And these jobs kind of run overnight, whereas we do additional kind of joins and additional data set curation within the visualization, but at least all the hard stuff is done. And all the really steadfast rules around how to key the data are kind of handled. And we do like to do a lot of change data capture kinds of activities during our staging so that we can capture transactional history. And you're not going to get that by curating data sets and making them directly available within like a Tableau.
Yep. Okay. And then there's a question here, I guess maybe Colleen, I'll throw it to you to start with, but I'm happy to kind of, give my thoughts as well. But there's a few questions just about like snapshotting and kind of maybe life cycle management. And I think on one of the slides, I kind of called, I kind of referred to Amazon S3 as, the structure, the storage of the data lake. And of course, when we think about S3, it's not just a monolithic object store, that there are components like Glacier, for instance, that can provide that archival of data. But so if you're not familiar with kind of the richness of S3, I would encourage everyone to kind of take a look. We didn't really do a deep dive on S3 in this call, but I don't know, Colleen, does Dow Jones leverage any of the capabilities like Glacier on S3 for some of that archival data today?
Our project isn't old enough,
okay,
unfortunately, to utilize Glacier, but we do use S3 extensively, more so than Redshift, because it is cheaper and the performance hasn't been so, you weigh cost over performance, and performance, when you query the data the way that Spectrum expects you to query the data, you get pretty fast results and you can do almost anything that you need to.
Thanks. And then I'm just kind of going through the questions. There was a question about, does a data warehouse and data lake, are they separate? And, the point hopefully I was going to call out in my introduction, and I think, Colleen did a good job of giving an example of that. Really what we see is this merging of the data lake and data warehouse. And, if I think about a traditional architecture, typically the data lake really referred to an on-premise HDFS cluster running Apache Hadoop, and the data warehouse were, appliances like Teradata, Netezza, and kind of, Oracle, and kind of down the line there. And, one of the points we were hoping to kind of call out is that on AWS, like we start to see this world, joined together, where if I have a common storage layer, Amazon S3, where I'm not, paying the 3x replication tax of HDFS, but simply leveraging an object store, and those objects can be defined through the metadata layer called the Glue Data Catalog, that now I have a flexible set of options. So if I still have that Apache Hadoop developer that's, writing Spark or Java or Python and using Spark containers, they can access that same data catalog and that same files on Amazon S3. But at the same time, if I have analysts that are doing SQL and reports and dashboards, yes, you can load the data, as a traditional format into Redshift directly. But you can also just extend your data warehouse by an external table and leverage the serverless compute of a feature of Redshift called Spectrum to issue SQL queries against that same data catalog and that same file formats on S3. And so, if you wanted to design those worlds to be separate, you certainly could, but more and more we see this trend of the merging of, the Hadoop world and data warehouse world, and kind of, being able to choose the right stack based upon your use case and not be forced to build, individual data silos. So we're just kind of reading through a few more questions. You're talking about ORC. What about CSV? Is that suitable to store CSV files on S3? The short answer is yes. We have customers that, oftentimes will load CSV or JSON or, obviously a large set of file formats. And the reason I was kind of calling out, Apache Parquet and ORC is that, these are, optimized for analytics. And so, yes, like, could you just, query or analyze CSV files? The answer is, of course, yes. But if you're looking for a process where perhaps I move beyond just the CSV file and do some transformation or enrichment of the data, particularly where I want to query that data through SQL, then these columnar formats like Parquet become really powerful. And so, many customers will convert that CSV data to one of these Apache formats like Parquet, but you're not required to. Just realize that from a performance perspective, if I'm doing a SQL query against CSV, the performance and potentially even the cost profile could be different than some of the optimized formats like Parquet. Maybe for Colleen, I don't know if you kind of encountered that, file format piece with your data lake, but if there's any kind of thoughts on that question.
Our developers prefer Parquet, so everything that we bring in gets transformed to Parquet, and we store everything because it's the easiest for, excuse me, it seems to be the easiest format for everybody to work with, and it seems to have delivered fairly decent results when working with Spectrum.
Yep. Okay. And then there's a question about, could you add some comments about high availability options for the representation layer, through, Redshift or other queries? And I mean, there are a few questions about this. So I would say first is that, remember, we do believe this idea of, choice. And so first, if I have a set of users that just want to issue SQL against the data lake on S3, you can simply use Athena. And Athena by itself is, natively across multiple availability zones. But then in the case of Amazon Redshift, I mean, we're always like evolving and, taking customer feedback. So, I think we kind of understand the request here, but today you can actually have, Redshift in multiple availability zones. So if I have, my data on S3, and if I have that common data catalog in the Glue data catalog, you can have multiple Redshift clusters accessing the same data definitions with the, same data on S3. And so that's, I think, the most common way that I've seen that architecture designed. But then within Redshift itself, I would just call out that there are a number of HA options in terms of, the automation in terms of detecting and monitoring your cluster health as well. That can certainly help for single AZ deployments as well. So I'm just looking at a few more questions here. We talked about the different BI tools that can. So there's a question in here: can Glue generate a schema for QuickSight? So we didn't really explicitly cover it on today's webinar, but Amazon QuickSight is an option if you're looking for a visualization tool. It's completely serverless, which particularly when combined with a service like Amazon Athena and S3, you really provide like a serverless analytics stack on top of the data lake. And the data catalog is then exposed through Amazon Athena that can then be imported into QuickSight. So Glue does not directly generate a schema into QuickSight, but Glue generates the schema for Athena and Redshift Spectrum that can then be leveraged by QuickSight. So a little bit of a nuanced piece of the answer there, but Glue does not directly load into QuickSight. It simply, QuickSight would read the definition from Athena or Redshift, depending upon the service that I'm using. I think that's, I know there's still a few questions in here. We'll try to, continue answering in the chat window, and, we can definitely, follow up as well. But I think we're kind of at the end of the time. So I just wanted to thank everyone for your time and thank Colleen for sharing the use case for Dow Jones on the call today. And, we definitely look forward to speaking again soon. And we'd love to hear from everyone on the call, like additional topics you'd like to hear around data lakes or analytics that we can perhaps follow up with as well. But, thanks everyone for your time this morning.